Dan is pulling some very interesting things both out of the ceiling and off of the wall here. Dan, what are you doing for us here? What's going on?
Well, I have the Pasco bicycle wheel gyro.
Uh-huh.
And there are a lot of things you can do with the bicycle wheel gyro. I'm going to concentrate on what I think is one of the most astounding physics demonstrations that you can do for your students. And this makes it pretty easy.
And this is a staple in every physics classroom, Dan. I don't think I've ever seen a physics teacher not have one of these devices because of its utility of some great concepts to teach.
And hard to explain, some of them. So
right.
we'll see what
I can't wait to see
here.
what we get.
So what I always do is start off with just having it hanging by the rope here and point out that if I were to let go, it's not going to fall. What's it going to do? It's going to rotate, right? There's a torque from the weight of the wheel about this axis point here that would allow it to rotate. Now, if I spin it, then maybe something different will happen. And I've always spun things by hand, but this comes with this neat little gizmo to get it really spinning fast, which may or may not be a good idea. But in the interest of entertainment, we'll give it a try. So I just wrap it around here, kind of like those little toy gyroscopes. We usually can get... What?
It's a lawnmower.
Yeah. Yeah. I think I could do better, but it's spinning. I let go now, and the students might say, oh, it didn't fall. Let's give it a little more. That's how I always did it. They would say, oh, it didn't fall. Well, it's rotating just like it did before. It's just rotating in a plane that's 90 degrees from where you may have expected if you've never seen this before. And so sometimes you just end and say, hey, it's, you know, right-hand rule, it's a gyroscope, it's precession is the term for that. But we can actually understand it if we've gone through some basic physics already. So let's do that. So imagine the wheels spinning like this. I'm going to stop it a few times to explain some things, but it's always spinning like this. And I'm going to attach a particle to the wheel here. And if right here, as it's spinning, I let go, it would start to rotate toward me. At least it has that tendency, right? Now, the velocity of this particle is in this direction at that point. As it moves, it's still in that direction. In other words, its velocity isn't changing. So it doesn't have an acceleration due to that changing velocity, the momentary direction. So no force is required there, other than the centripetal force to keep it going in a circle. If it's here, then we have something different. As it starts to move, its velocity changes direction. At this instant, so again, remember it's rotating like this. At this instant, its velocity is up, and if it were to rotate 90 degrees, it'd be toward me then. And we know to make something turn like that requires a force perpendicular to the direction of the velocity. So the wheel would have to exert a force on this particle in this direction to make it go like that. The particle, according to Newton's third law, applies an equal and opposite force to the wheel. And so there's a force out on the wheel from the particle. Now if the particle, so here there's a force out. Now if the particle is on this side, and again the wheel's spinning like this, and if the wheel started to go like this, well, what's going to happen now? At this instant, the velocity is down. And if this were to start rotating like this, it would be moving more out towards you. So how would you make something that's going, has a velocity down, turn out towards you? You'd have to apply a force like this. So the wheel would have to apply an outward force on the particle. Newton's third law, the particle applies an inward force on the wheel. So if we combine that, had another particle.
It's right up above the camera. Yep, right there.
I made them easy to see.
Yeah, they're there.
And I couldn't see it. And so this one, there's a force in on the wheel from the particle. Here there's a force out, so that's a twist. So what we're doing is predicting if the wheel's spinning like this and I let go, then it should twist like that. And that sort of works. And so you can give an explanation. It's not complete, but an explanation that introductory physics students could understand. They may wonder, hey, it's a whole wheel. Well, you could add up effects of particles all along here, which would be less and less and less. So by focusing on these 2 points and the place where there's no effect, you can put that together and get a good picture of this. And so
Awesome,
that's the
Dan.
bicycle wheel gyroscope.
Dan, the thing I really love about what you just did is you took something complicated and you just used Newton's 3 laws to explain it. And one of the things that I know when I was doing things similar with my students, I would say like a force in a direction keeps going in a direction unless acted upon, which is what you just demonstrated very nicely
Right,
with this.
taking what they've already learned to understand something, at least get more understanding about something that's very complex. We'll find out there's more to it, I think, in our next demo.
All right, because we take it a step further. So
Yeah.
thank you, ladies and gentlemen, Mr. Dan Burns on the bicycle gyroscope.